Okay. I wish I'd reviewed this one. So, welcome everyone to my talk about extension exploits and rootkit in your browser extension. I must say that, well, it was a pleasant and really adventurous experience to come to Norway. The first day I came to Norway, I actually broke my hand on the snow. I felt like I was frozen, and it's not a good idea to do. But nonetheless, I love all the snow, and it's beautiful. And I experienced your healthcare system, and it's so good. I must say, it's amazing compared to Israel. So this is like the main context here. I'm really excited, although all of that, to give you the best talk about extensions and to really show you how to break and make new and cool things out of it. So with that in mind, let's start on. So our adventure starts actually with speaking a little bit about myself. So I'm a security researcher. I love hacking and breaking into things. I founded a company called Wild Pointer. I do security services, pen testing, research, and much, much more. I previously was an author at Sentinel-1 Labs, doing my own research as well. Hacking smart home devices for fun and profit, actually destroying my parents' house would be rather a better name for that. I did my master's in algorithms, bioinformatics in Tel Aviv, and I love vulnerability research, IoT, embedded devices, web apps, and while much, much more, CTFs. I'm also actually a DJ, and I really love parties, so you can also check my Mixcloud as well. With that in mind, let's dive deep into extensions. So what is my motivation about extensions? So first, there are more than 2 million extensions in the web stores. So Chrome web store is filled with also good extensions, but also malicious ones and exploitable ones. And I will explain, of course, what it means, exploitable ones. So why they are used for extension, why extensions are used for malware is, well, they are really easy to develop. Like, for example, if you need to develop a full-armed, native kind of C binary that does all the post-exploitation and exploitation mechanism, it would be much harder than, well, just write JavaScript code that scrape for your browser, extract cookies, and get all the data it needs only from the browser side. And not only, you get the still free because you're running Chromium context. So it's highly targeted thing for attackers to do. It lets you control your browser, give you permission like you access to any site, so you can target any region, execute JavaScript in this region, and much, much more. Also, it cross-platform, which is really cool. In a sense, well, desktop only. Desktop are extensionable. You can do extensions in desktop version of Chrome. In Firefox, you can do it also in other ways, but I'm focusing in this lecture in the popular Chrome browser. So why did I research extensions? So as you could tell, I'm enthusiastic about research in general, and I find out there is this cool attack surfaces inside the browser, and this new kind of APIs. Well, for me, they were new. That expose the extension and how they work and world and so on. They lie in different contexts and they have this super browser power. For me, either one of them would be enough to fully on research them. So the syllabus will be today. First, we're going to discuss about what is Chrome extension. Then we're going to deep dive into the communication routines, going to exploit two extensions, the first in two different cool attack vectors. The first is the Zotero extension, widely popular academic research kind of extension. We're going to jump from one Chrome app, Chrome extension to another. And the other one would be the Vimium extension, in which we abuse him and exploit him to get UXSS and eventually run code, JavaScript code inside any target origin we want to. All of these vulnerabilities were disclosed. And the last bullets, I will discuss about how to implement a rootkit extension. For example, you already ran code on the system device, on the victim device, and you want to use the browser as an evasion technique and as a technique to implant a rootkit that you can return back or use similar kind of to Cobalt Strike kind of thing, but again, with less privileges. Then you can use these techniques to gain persistence in the browser. So I will show all of this and much, much more. And with that in mind, let's dive in. So the basics. The basics, like every good kind of web app, we have the front end and the back end. So the front end is the content strips. They call it the content strip because they are related to the content in the websites. They loaded inside matching websites. So you, as an extension developer, need to define which sites should load also, should be loaded with your extensions. So it's really useful, for example, for AdBlockers. AdBlockers are running in every, for example, every website, and they can that way inspect the DOM elements and everything they want and see what is going on in the site that they are being loaded. This is on the contrary to the backend. The backend, which is the background context, is actually the persistent area of the extension. So this is the more maintainer, admin area inside of the extension itself. It has more API, more privileges, and it always stays up. This is usually the one that always stays up going on. And the content strip is the only one that have direct access to the DOM elements, okay? They have direct access to the DOM elements. And content strip, both background scripts have the origin, which is Chrome extension / Chrome extension ID, etc., etc. I will discuss it later. You don't need to remember it right now, but they both have the same origin, and therefore they can communicate with spatial APIs between each other. So this is the backend and the content. And on Windows, the extension directory is on local app data with the extension ID, as you can see here. There is also the extension manifest, which is like, if you know manifest.xml from Android APKs, it's really similar. It's a cool thing to define how the extension works and what is inside of it. And the extension signature, which is in a metadata folder. It's a different folder that contains kind of publicly signed SHA-256 hashes over all the resources in the file, including JavaScript, HTML, whatever you want. Like, they are all signed. And you say, okay, but they're verified ones, so I can maybe replace them on the runtime and then do cool things. Well, no, they are actually verified on runtime, and not only when they are getting loaded. So every time you change and reload your extension, Chrome verifies them. So if you just change JavaScript inside this directory, the extension will stop working because Chrome will identify something was changed. Okay. So this is the extension. This is the manifest. You can see your cool manifest. This is definitions. The background area is the cool JSON. Background contains the script that are the persistent in the background, content strip, and the matching site. You can see content strip and the site that they should be loaded into. You can see the script's names, and you can see the all frame, which is sometimes being used. Well, as far as I see, usually being used. It actually means that the content strips of the extension are loaded inside every iframe as well in the tab. And you can see that the content strip has its own scripts. For example, here, content strip filename.js. And this is the second part. And on the third bullet, you can see two important things. The first is the web accessible resources. These are resources inside the extension directory itself, which are exposed or being able to be exposed to users, to sites. So when I say that, I mean that you can access this as a resource and consume this and expose it, for example, as your own iframe. You can add an iframe that points out to internal Chrome extension resource. But it must be defined by the extension, so it's not security vulnerability on its own. The extension defines what is exposed to other websites. So this is the first, and the second is what you expect, permissions area. The permissions area is what permissions the extension have. Have a permission to get the cookies, the storage, its local storage, Chrome storage kind of thing, history, your tabs. You can execute JavaScript, for example, in your tabs. Notifications, and much, much more. Okay, so now let's go through the communication. So I was seeing it the first time, and I was really like enthusiastic about it because I never seen such like, well, deep kind of thing between the browsers. So you can see that, for example, if google.com is running inside my browser, on the left side, you will see the web context. You can see here the DOM elements running in the context and the scripts, the Google scripts running on the left, and they have access to the DOM scripts. All good. Let's say my extension is also matched for Google. So it means that the content strip of this extension can be run inside that website. So you can see on the right, there is the extension context, and it's freely accessible to the DOM elements inside Google. So the content strips I have in the extension can access the DOM and can change everything in Google, everything I see in Google. And on the right side, you can see the background context, the backend I told you, running once and communicating with all the front ends on different sides of the extension that are getting loaded and loaded again. So we have, again, the website on the left, Google, and we have on the right both the content strip, which is the front end, loaded inside the context of the DOM element, the google.com, and it is communicating with the background of its own extension through message passing, through its unique API for extensions to send message between the front end and the back end of the extension. Okay, so content strip can communicate between background and back and forth, and you can see that all these mechanisms working together flawlessly to, well, maliciously run code or hook or trace your device. I don't know. So this is the communication in our extension lab. Let's now go deeper inside this communication routine. So let's start with the easier thing. Communication between websites and the extension's content strip. Okay, so first of all, we have cross-origin messages. We can just send messages to that Chrome extension origin, target origin, post message, cross-origin messages, simple post message JavaScript APIs, and it will be sent and delivered to the content strip of this extension. So this method can send cross-origin messages from other websites. And what more can happen is that, well, DOM elements changes in this element change in my website can also be hooked and introspected by this extension. So the content strip can introspect these changes as well. And the last thing I speak with you about is actually the accessible URLs. The accessible URLs are the URLs, internal URLs inside the Chrome extension itself, which are exposed to the websites, to the users. So you can see an example here. For example, if in the manifest, one URL is written in the web accessible URLs, then you can see on the second line that the website can actually add an iframe, which is source is internal location in the extension folder itself. Okay? In this scenario, you can see the iframe.html on the last line. Okay, so this is the first way of communicating, website versus extensions content strips. Now let's go to websites versus background scripts. So what is the communication in between them, what they can do to operate? So first thing is that the background context, I told you, they have much more privileges. They can just inspect, hook, and proxify your entire network without you even knowing that. So they can add on before request, they can add on before response, which are kind of hooks that can inspect your communication, your request, your browser request, you request images, you request a website, whatever, they can inspect it with different APIs exposed only to extensions, only to background context in extension context. So this way they can trace it, and you can, of course, it's an attack surface for the websites to try to maybe hack or inject something into the background context. Second, tabs, cookies, storage. They are also can be inspected by the background. So everything you change in the cookies area, in the tabs, and so on, is exposed also to the background, and they can inspect it and use it. And the last one, which I didn't really discuss, but let's discuss it now. It's a cool technique which can be added inside the manifest, which means that if you add specific site or extension name to the manifest under the name externally connectable area, then these sites can be connected directly to the background. So what I'm saying here is that there's another way to communicate not with the content scripts, but with the background scripts directly, as if you were a content script. So for example, you have your own site. I'm a download manager, and I'm surfing to my download manager site. I want to expose API capabilities of the background context to this site. So what I do is I add in the manifest capabilities for this site. And when I do add it, it exposes new API for this site to send messages to the background of the extension. And this is the externally connectable pages. You can see an example of how this data can be sent in the background on the last line. Cool. And the last is extension versus extension. So communication of extension versus extension, of course, contains all communication that is website versus extension, of course, but it contains much more. So externally connectable sites extension can be also allowed. And sometimes also TCP and UDP connections, if you have the correct permissions, can be used to do some stuff. Because if the extension itself listens or connects to a specific endpoint, then you can do things with that, or intervene or introspect, and do many things with that. And the last thing I want to show you is a small trick I found out. You can see here that even if I'm not able to externally connect to this site, I'm on another extension, but the first extension can be connected externally from one site. Let's say this site is extension2.com, then I can inject JavaScript code as an extension to this site and then make it seem like I'm operating from this site, sending my own data to the background context of another extension. So this is a trick actually to bypass this externally connectable thing to send from one extension to the background context of another if the second extension contains this interface, contains this definition for this site. Okay, this is just a cool one technique. And now let's go to the real deal. So Zotero extension. Let's speak about it a little bit. So Zotero extension is having more than 2 million users. It usually goes with, but most people doesn't install the Zotero desktop version that have kind of local repo that contains data citations. It helps you allocate and manage all your references and much more. It helps actually academic research ongoing. I actually use it in my thesis. I'm now a little bit feeling ashamed about that. And well, that's what my target is. So let's see what we can do with that. So first thing, I found out that there is this cool mechanism that's called the Zotero Translators. And the Zotero Translator is a really cool technique that, well, they told themselves, okay, we want to get citations for papers, for sites, for academic research. But every time you go to a site, you don't know which type of data you want to extract, which type of information you need to extract to make these citations. And voila, there come these translators. These translators are actually tiny JavaScript, well, not that tiny, JavaScripts that actually extracts data from the current website in order to help you citate this and do reference to this site much more easier. So this is the translators, and you can see that well, it's a cool thing. I'm not going to discuss it much more, but there are more than, well, 500 JavaScript translators inside an open source public repo. And I'm like, okay, come on. No one ever managed to go through all of that and security audit all of that. It's like tons of JavaScript, and they run on every site inside the Zotero extension on the content script area, and all the users use this. So supply chain attacks, yes, probably should be inspected more, but I'm not going to discuss that. Because another better thing is that, well, don't we all love auto-update systems, right? We love auto-update systems. So Zotero Translators, what it's doing in order to update, of course, you want to download more JavaScript because 500 JavaScript translators is never enough. So it tries to download more from its own repo. And usually this repo can be installed locally with the Zotero desktop software version. As far as I know, not many people install that. So it just go to localhost and see if the port is open. If it's open, it get a translator, do the full update, and so on, and actually get new JavaScript code, doesn't verify anything, and run it. Run it inside the content strip. So yeah, this was kind of the exploit. You can develop a Chrome app. Well, Chrome app is going to be deprecated, I think in this end of the year. When I've written this, it was completely affected, and it's all good. There are a lot of other techniques to use this in other methods and ways to attack the scenario, but nonetheless, it's still a simple thing you can install. You can install easily. It seems like a Chrome extension. It's type of a Chrome extension. And I have only one permission, which is the TCP server. I listen to this port, serve my own translator JavaScript, and that's it. Run code inside the content strip. Oh, the funny thing, you can see that this is the execution of the JavaScript itself. You can see actually the sandbox manager written here. So yeah, they actually thought about it. They running eval in a sandbox manager environment. Well, no, it doesn't do nothing. This sandbox manager doesn't obscure nothing. It doesn't secure anything. Sorry, and it just does eval, and I have access, therefore, to all content strips in Zotero. But I'm like, okay, why stop here, you know? I just break to more things. Like, I'm in the content strip zone, but I'm temporal. I want to break also to the background context, right? Yeah, why not? So let's now explore the attack surface inside the content strip. So they have the send messages. You can communicate freely between the background context, back and forth, with the content strips. You can access to shared extension URLs. Remember, now my origin is the content script origin. So I can actually access all these origin URLs, all the extensions URLs. Maybe it can give me something unique and much more special. And also there is a storage and configuration that is being used. Okay. And I'm like, okay, sorry for the language, but fuck it. I'm like, let's search for eval in the background, right? I search for eval in all the background to find if they using the same kind of thing again. And well, voila, there was this Google Docs integration, RCE running code kind of thing. I don't know. Well, there was an interesting eval there. And let's see what happens. So when I explore the background context, remember, I'm in the content strip and I want to jump and execute code in the background environment in order to be persistent and gain more privileges, okay? So in the background context, I see that it gets some data from the preferences of the extension itself. It uses this data as the repo URL, and it downloads, again, JavaScript code to execute and to run as, well, of course, a Google Docs integration. Yeah, that's what we all want our backend context to do. and this is what happens in the background. But it seems a bit more easy than we might think. Because what's the problem here? Now it doesn't do any TCP port communication. It just uses the preferences. And these preferences are, well, they are background preferences. We can't affect these preferences, right? It's like, it's total disruption of the privileges between the content strip and the background. If one from another can inject configuration, it could be wrong, not? Well, we can do it. Sorry for this slide. It doesn't relevant to what I said now. This is actually the code being executed. You can see eval. They didn't even bother here. They didn't even bother here to place a sandbox manager. No sandbox manager. They didn't even bother. It's like, do eval. It's all good. So I want to reach here. So let's now get back again to the configuration. So in the last slides, I've shown you that in order to the background to use this JavaScript, it needs to download this JavaScript for my URL and to know it needs to download it from my URL, I need to change the preferences. I need to change the preferences of the extension itself. So I actually found out that Chrome Storage Local is actually shared, and it's shared between all the extension URLs freely. And when I eject new configuration, it just pops up in the background. So I could easily inject configuration from one context. It would pop up in the background context, change the URL of the repo, download my JavaScript, check. It does simple check. It doesn't verify any integrity. It does simple check. Yeah, the version is big enough. Yeah, my version is 200 million stuff. Download and install me, please. And it will. And yeah, very cool. So this is like the way to exploit from the concept to the background. And this is going to be the demo video. It's all going on the background, so you don't see really anything really interesting, but I show you how it looks like as a victim perspective, kind of that doesn't really know much. And I will show you also the C2C servers. So I'm opening TCP port, I'm executing. You can see this is my app, this is my Chrome extension. And one cool thing you can see here is that it doesn't have any access to any site besides one permission. No access to any sites. My only permission is just to exchange data with the network. That's it. The TCP server one is my only permission. This is the Zotero. This is going to be the extension we're going to attack. You can see that this extension can read my old browsing history. And this is actually kind of common thing for extensions, accessible to all sites. So you can see it here. And on the way, I already exploited and managed to do the chain itself and to run code. This is the C2C server, and this is how it looks like. You can see also the demo. I have a GitHub repo that shows that, but it automatically sends data. And the cool thing, you don't see anything in the network. Although I'm accessing all the DOM elements inside this page and getting all the data, you won't see anything inside the dev console, the dev tools, anything, because I'm lying in a different context. And this is the cool thing. I'm writing here something. All seems to be good. You can see here, nothing was being sent in the network. Nothing which is mine is being sent. Although nothing seems to be sent, I'm taking all the data and sending it for a different kind of context at all. And you can see it running for you. Okay, very cool. So this is how we're exploiting Zotero. Now let's go for another extension. So Vimeo. What is Vimeo? So Vimeo is an extension that actually really cool extension, and I felt a little bit bad doing that because I love it, you know, like I use this extension, but nonetheless I'm making it more secure, so that's good, and it's making your browser Vim-like browser. For example, when you click a button, then all the things in which are clickable become letters, and you can just click the letter you want, press enter, and you just navigate to there. So it makes you really easier to surf the web, to navigate for sites and much more, search for other tabs, search for data, and much more. And my attack scenario here was not jumping from one extension to another. I'm going to present another attack vector, which is I'm going to exploit this in order to bypass SOAP. So my goal here will be, you are a victim, you have already Vim extension installed in your browser, and a user enters my site. This victim enters my site, and this Vim extension is installed, and I want to use it to abuse it and to bypass SOAP and to run actually JavaScript code inside the victim context in every site, Facebook, Google, whatever. I want UXSS through this extension. Okay, so let's now explore again our attack surface. So our attack surface include the widgets. We have the Vomni bar, which is like a cool search bar. We have helper, we have visual mode. I don't care. The Vomni bar is the running code widget, so let's focus on the running code widget. So how it works, you can see on the left the Vomni bar. On the left, this is the website context. On the right, this is the content strip side. So whenever I click O and press enter, then the content strip, remember again, they are accessible to the DOM area. They hook and catch my click, and they now open new iframe. This iframe is the vulnerable iframe. They add it inside. You can see here on the left, this being added dynamically because of my click. And this is an iframe which is origin is the same as the extension origin, and then it authorized to this to the iframe with post message and send secret token shared by both of them. So what did I want to do? Well, of course, I want to bypass this authentication, and I want to break the secret. In order, my main goal here will be, I thought it would be nice, just communicate freely with the vulnerable. So I wanted to send commands to the vulnerable. The vulnerable executes auto-completion, search things, and much, much more. So I thought it would be helpful if I could bypass this authentication on the third bullet here and to communicate with this vulnerable. Vulnerable is an accessible URL, so I can inject it as a new iframe inside my site, try to communicate on behalf as if I were a content stripped on myself, and let's see what happens. So how to exploit it? So I will insert vulnerable iframe. I will try to connect it, bypass the authentication somehow. I need to send a secret. I don't have the secret. And then I send the vulnerable commands. Okay, that's a very nice idea in general, but like, what is the secret? So going deep through the secret, you can see that it initializes once when Chrome runs, and on a different process, the background context, and yeah, it's a very state-of-the-art random number generator. Very, very, you can see math.random, which is actually breakable with XOR shift algorithm, XOR shift P128. So it's breakable if you have some samples, but because I'm not running on the same process, I don't have enough samples to use that, so it's not breakable in my scenario. But you know what? The randomness here is only 2 to the 30 bits, not such a high entropy. Let's just try and break it, you know? So this is the brute force. Brute force in this post message, trying secret one after another. If it works, I'm getting success message. If not, and I have an open port, this is the post cross origin messages, post message routines. If not, I'm getting no response. And the cool trick I added to make this brute force actually possible is that I'm using web workers. And web workers are amazing. They can actually help you, like they run in the background, even when you don't see the tab, the computer, the screen is shut down, you don't see anything, the browser is not open, nothing is open, it will still run in the background. And this is really cool and really helped me making this brute force feasible. So I use this to run it again. Of course, if Chrome will be closed and, well, and your PC will be closed, of course it won't work, right? But whoever close its PC, am I right? So with that in mind, we've broken now the secret from Vimeo, and let's continue breaking more things. So commands, remember now my attack scenario, I can communicate and send commands freely to the vulnerable itself. I can trigger search for new URL completions. This is the type of commands I can send to the vulnerable on behalf of the content strip. So now the vulnerable think I'm a new content strip, and I can communicate with him freely. I can activate search and jump to new URLs, and I can search for ints and auto-completions, and yeah, I can run JavaScript code as well. Yeah. So let's see how it works and how the magic happens. So if you open vulnerable iframe, you can write also a JavaScript scheme. Why is that? Is because, well, it's one of the features of vulnerable. It will help you search and navigate the web easily. So when it sees that, it tries to auto-complete it with one of the results it already have. And because it sees its JavaScript scheme, it just, well, voila, it says, okay, it's JavaScript. I just execute, because you are the Vim hacker and you want to execute JavaScript, right? So I will execute the JavaScript that comes after the JavaScript scheme. Nice. And it's cool thing, but I'm running code inside my own website. It doesn't give me anything, right? Like, why do you even care? So inspecting that a little bit more, let's see what happened. What happened is that the vulnerable iframe tries to find auto-completion. It actually triggers the content strip because the vulnerable iframe is in the same origin as the content strip, so it can send messages to the content strip and to the background area. So it sends message, please autocomplete me, to the background context of the extension. Now the background context of the extension sends back to the tab, okay, this is a JavaScript, just run this JavaScript over the entire tab. So all the content strip inside this tab will get the message, run this JavaScript inside this tab. They get in this message and they just execute this JavaScript inside of them. And maybe you can think about one problem with this scenario. Well, the problem is that the message being returned is not returned to the original content strip that is sending the message. So yes, this is the whole exploit right now. I will just add a new iframe inside my website of the target origin I want to attack. For example, I add a new iframe of google.com or facebook.com. And because Vimium is Vimium, the content script of Vimium is loaded inside this iframe as well. And when the message from the background context will be received to the tab, all the content script will receive this message, including the other iframe, which I don't have any access to. But it will receive the message, please execute JavaScript on my behalf. So I managed to make the vulnerable iframe send a command on my behalf to the background, which ping-pong back to another iframe. And this another iframe is the original iframe which executes my own JavaScript. I will show you that in much more clear way. So on the left now is the content strip area, not the website, content strip. On the right side, you can see the background context, okay? And you can see now that this is the first thing I'm doing. I'm triggering content strip sending message to autocomplete. It's now going to autocomplete the vulnerable JavaScript scheme as I showed you, and it sends a message to the background. Please autocomplete me. So I trigger it, and the bullet number 1 is from the original website. This is the attacker website, the example.com. But I placed inside of it another iframe of the targeted origin. So now the background context get the message and say, okay, I received the JavaScript message. Okay, you should just need to run JavaScript inside your tab. That's it. And it sends this to the whole tab. But now also this tiny iframe over here also get a message, because this iframe also have its own content strip of Vimium. So it also get a message, execute my JavaScript. I'm getting the message as well in my website, but I don't mind. So I'm executing message again in my context. And that way we can execute arbitrarily on any target origin JavaScript using Vimium. Okay, so to conclude, the high-level exploit for Vimium would be, well, we'll first insert the vulnerable iframe, then we'll connect to it from our page and break the secret, break the PRNG secret. By the way, I disclosed this vulnerability, so, well, hopefully it won't be that easy to break the secret right now. And so we need to bypass the authentication PRNG. Then you trigger the autocomplete routine, which trigger all the things we talked about before. So you trigger autocomplete in the vulnerable with the JavaScript scheme, which sends to the background context the JavaScript autocomplete. Background context sends back to the tab the message. All the tab content strip get the message. Specifically, my iframe, the targeted iframe, get the message, execute JavaScript, and you just run JavaScript in that region. So this is an example of how it will look like. It's really raw, it's really draft. You can see this is the version. They fix it so the current version is higher. This was the latest when I developed the exploit. This is the site itself. Yeah, the UX says the game. All you need is enter from the user, and you can see that Facebook was triggered. You got an alert from Facebook on the background, and it happens because I'm continuously making auto-completion for the JavaScript scheme. So it sends back to this iframe this data. And you can see, well, as a victim, of course, it's not a nice thing to see, but I can really make sure I can really cover all of this up. So if the victim can see anything, he would just think he's playing in a nice video game when you have to press one enter and you just win $1 million. He will press it, you know? So this is about Vimium extension. And now let's finalize with the persistent JavaScript extension, or we gotta love K-Impact. So now that ActiveVector is post-exploitation method, we want to implant our own rootkit inside the browser. And you want to have a full browser access and also full file system access. So what is the cool thing here is that well, the file system, when you access it from your own process, of course, it will be notified. Anyone will know that. But if, for example, I will access the file system disguised by Chrome process, well, it would be much more harder to suspect that, right? So I will show you how to develop a rootkit that also have full file system read access as well. And the first thing that is a challenge to us is that, well, extensions are signed, okay? The extensions are signed, they are verified at runtime, at any moment, they are verified at all time. And these extensions have their signature in the metadata, and if I delete the signature, Chrome will download them again, it will verify them according to its public key, but what happens if I'm a developer? I want to test my extension. I need to sign my extension every time? No, of course not. So developer can actually operate in unpacked mode. So when you operate in unpacked mode, so you can just load the extension with ---- load extension, and Chrome doesn't verify any of your extension signatures. Okay, that's cool, But I don't want to add more extension. I don't want the user to know that I'm there. I don't want the user to know anything. I don't want to add any more extension to the extension list. My main goal is just to replace and modify old extension and inject small tiny backdoor, small tiny rootkit that lies deep inside of it. So yeah, if you thought about it, you're probably right. The exploit will be, let's pick an already installed extension. I don't know, your AdBlocker, Google Sheets. Actually, on default, Chrome have extension installed already, the default Chrome extension. So pick even one of them. And when you pick them, we just need to add to the Chrome arguments, to the Chrome shortcut, to the Chrome argument itself, ---- load extension. And instead of pointing that extension to a new path, a new extension I will put, I just place there the old directory, the old extension. So what Chrome will do in this scenario, it just think, okay, oh, you develop now. You are now the developer of AdBlocker. Oh, it's all good. Just continue use AdBlocker as it is. You can modify and do whatever you want. It doesn't notify the user anything. You don't have to be in developer mode as far as I checked it. And you can just change the AdBlocker to add anything you want maliciously. Actually, some similar techniques have been used since I gave this talk in DEF CON back then, this year actually, and they used it to steal to modify Bitcoin kind of wallet extensions to steal and hack Bitcoin. Not this method, kind of similar, but still they're using these kind of methods out there, and we need to be much more knowledgeable about that. And what is the most cool thing about it? I can modify anything. I can add permissions. I can add anything to the manifest. I can insert and add the highest privileges as an extension, because now the signature of my extensions aren't verified. They don't verify my signature because I'm a developer, right? I'm developing. So this is how it looks like. Well, this was the latest. It works in the latest as well. You can see AdBlocker is installed. Chrome doesn't notify me anything. Installed correctly. The AdBlocker Plus installed beautifully. The ID is the correct ID. I'm not skimming anyone. You can see a small tiny thing near the icon of the AdBlocker, but it's really hard to notice that. And when you inspect the background context, you can see that I ran JavaScript code in the background because I modified the extension. They don't check the signature. They don't know nothing with that. And no alerts to the user. And that's it. So that was really cool. And I finished with my cool GitHub repo, which called Maltensions, where you can develop and generate and test your test malware techniques inside your browser. You can really like produce kind of things and test them. They have lots of techniques, so you can freely use this GitHub repo on your own responsibility, of course. And the feature techniques include full file system access demos, POC to inject and run JavaScript inside hidden context in the browser, so you won't be recognized inside special VM context, CNC communication, and much, much more. So to conclude everything we discussed today, well, first piece of the extensions are possible. We can jump from one extension, the attack surface from one low privilege extension to another is a truly possible thing. The second is that, yes, detection will get harder because who even know what's going fully inside his extension, inside his browser? And the attack surfaces, there are huge attack surfaces to explore. I think I just got the tip of the ice. Now we've manifested with free and things that are going to replace that. We have a lot of attack surfaces and new things that are going to be connected and integrated together. We need to inspect much more. And, well, this depends on which side of the map you are, but unfortunately, or fortunately, malicious extensions are here to stay. So with that in mind, I want to thank you all for coming today. I had a great time giving this talk, and that's it.